Welcome to Brainbox. We will now look at some more information about the reflection. As we have defined, whenever there is a boundary which separates medium 1 and medium 2, let us say this is medium 2 and this is medium 1. And here, one thing you need to understand, medium 1, medium 2 can also be segregated as the rarer medium and denser medium. Rarer medium is lighter, just like air. Air is a rarer medium and denser medium. Denser medium. Rarer medium is lighter. Example, you can take air. And here example, water or glass. These are called denser medium. So here, always we need to calculate the angles with reference to the normal drawn. So this is the normal. So normal is perpendicular to the boundary. Now let us say a light is incident in this direction, then is reflected back into the same medium, and here let us say this is I and this is R. So here you need to remember the two laws associated with this. So this is what the normal we are saying. This is the normal. So here you need to remember the two laws associated with this. That is, we call them as laws of reflection. Here the very first law is the angle of incidence is equal to angle of reflection. So one point you need to understand, here if at all the ray is incident in this manner, it will get into the same medium by making the same angle with the normal. Here pictorially it is seems to be R is more than I, but practically with whatever the angle it incidents, with the same angle it will be reflecting back. That means angle I must be equal to angle R. So this is the first law. Law says angle of incidence is equal to angle of reflection. Then second point you need to remember, incident ray, here by looking at the picture you can see incident ray, normal and reflected ray. Reflected ray lie in the same plane. Lie in the same plane. This is one more point you need to remember. This is called as the second law. See here, this is a medium 1, medium 2, rarer medium, denser medium. Here what is happening? I is in the medium 1, normal is also drawn in the medium 1 and reflected ray is also in the medium 1. That means all the three things are to be in the same medium. If at all the ray undergoes a reflection. So these are the two important laws you need to remember. Further, we look at the concept of refraction. Here it is a little beyond the scope, but still I'd like to give you the concept of refraction here. So refraction in the sense, if at all the second medium allows the light. So as an example, we'll just look at, this is the boundary, here is the boundary, and above the boundary there is an air medium, let us say, which is lighter, and here water medium is present, let us suppose. So this is the water. So here what is happening? Whenever a light is falling from the rarer medium to denser medium, that means lighter medium, air to water. This is the normal as usual. Normal you can draw like this. So the normal to the surface is this as usual. So this is the normal I am taking. Now with reference to the normal, a ray is incident like this, let us suppose. So into the denser medium also you can take the normal. Normal is always perpendicular to the boundary, irrespective of whether it is rarer medium or denser medium. Then obviously it is going reflected. A part is reflected here because water is allowing the light ray to get in. So in that case what happens? This is going to be the undeviated path. So if at all the water medium is not present, the ray would have been travelled in this direction. This is called undeviated path. But because of the presence of water, it is bending towards the normal. That means actually the ray is coming like this. So see here, you need to remember the different terms over here. Whenever a ray is incident on a boundary which separates the denser medium and rarer medium, here it bends towards the normal inside the denser medium. This phenomenon is called, this I call as the small r here, and this I will call as the capital R, this I call as the small I. This is undeviated path. This is called as refracted ray now. This I can call as incident ray. And this is going to be undeviated path as usual. Undeviated path. Here it can be undeviated. Now from laws of reflection, you can say that angle I is equal to angle R here. Here I am representing with capital R because one more angle I am representing with small r. When light enters from rarer medium to denser medium, angle of refraction is less than angle of incidence. You need to remember this. And similarly, when light ray moves from denser to rarer, as an example I'll just look at, here it is the denser medium, this is the denser medium, and when light ray is starting from the denser medium, this is the normal. If I suppose light is incident like this, from the denser medium it is coming, then it will be moving away from the normal. Let us say this is the angle of refraction and this is angle of incidence. Here you can see that R is greater than I, passes from denser to rarer, denser to rarer. So these are the laws of refraction in fact. This is the law of reflection and this is law of refraction. So small r I am taking over here. Incidence angle equal to capital R, that is angle of incidence equal to angle of reflection. But here when it is passing from air to water, it bends towards the normal. So here you can define the refraction as the phenomenon of bending of light towards the normal when it moves from rarer medium to denser medium or from air to water medium is called as refraction. So see here, this refraction angle is nearer to the normal. That means I is more than R. It is bending towards this. Actually it would have gone like this, but since the medium is changing, it is not going, it is bending towards the normal. So this phenomenon is called as the refraction. Of course the refraction is a little bit advanced topic for your class, but still you can have the definition part of refraction. But in detail you should be clear with what is reflection, and what are the laws